Welcome to TechDaily.AI, your source for technical information. This podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup and disaster recovery, hyperconverged in VMware, Hyper-V, Proxmox Cluster, AI servers, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com. Today, we're diving deep into something you've almost certainly run into if you've built, well, pretty much any modern web app, CORS.
Yes.
Yeah,
CORS, cross-origin resource sharing. It's fundamental, but can definitely cause some headaches if you don't understand it.
right. It's like this invisible barrier that sometimes just pops up. We're thinking of it like a bouncer for your browser deciding who gets access across different websites.
That's a great analogy, actually. It controls which websites can ask for resources from other websites. We'll break down what it is, why it's really crucial for security, and how that whole process works.
Okay, so let's start with the why. Why do we even need something like CORS? Why can't my browser just fetch data from anywhere?
Well, imagine the internet without any rules like that. Say you're logged into your online bank in one tab,
Okay.
and then you open a, let's say, less trustworthy site in another tab.
Yeah.
Without any restrictions, that second site could potentially make requests to your bank behind the scenes.
Oh, wow. Okay, that's bad. Really bad.
Exactly. That's why browsers implement the same origin policy, or SOP. It's a core security feature. Basically, it says a web page served from one origin can't just freely make requests to a different origin.
So, what defines an origin? Is it just the domain name?
It's actually three things.
Yeah.
The protocol, like the HTTP or HTTPS, the domain name itself, like mycolet.io, and the port number, even if it's a default one, like 80 or 443.
Got it. Protocol, domain, port, all three have to match for it to be the same origin.
Precisely.
Yeah.
So your app at https.mycolab.io can easily talk to https.mycolab.io API, same origin.
Makes sense.
But trying to talk to https.somnotherapy.com, different origin. The browser, by default under SOP, will block that request from the JavaScript running on your page.
Okay, so the same origin policy is the default lockdown. Then Chorus must be the way to unlock it.
Exactly. CORS, cross-origin resource sharing, is the mechanism that lets the server at https.somnotherapy.com say, hey, browser, it's actually okay for https.mycoolApp.io to access my stuff. It's the permission slip.
A permission slip from the server. How does that work technically? Is it like a secret handshake?
Kind of, yeah.
Yeah.
It works using standard HTTP headers. When your front-end code at https.myoop.com tries to fetch data from, say, https.api.example.com,
Yeah.
your browser automatically adds a special header to that request. It's called the origin header.
And that just says where the request is coming from, like origin.https.myoop.com.
Exactly that. It just announces itself.
Yeah.
So the server at https.api.example.com gets this request and sees the origin header.
Okay, the server sees who's asking. What then?
Now, the server has to decide. Based on its own configuration, it checks if it wants to allow requests from https.myoop.com.
And if it does, how does it tell my browser? Yes.
If it decides to allow it, the server sends its response back, and importantly, it includes another special header. Access control allow origin.
Ah, the famous one.
That's the one. The value of this header will typically be the specific origin that's allowed, so it might send back access control allow origin to https.myoop.com. Or sometimes, maybe to allow any origin, though that's less secure usually.
Okay, so my browser gets the response, checks for that access control allow origin header, sees if it matches my site's origin.
Right.
And if it matches, bingo. The browser lets my JavaScript access the data.
Bingo is right. But if that header is missing, or if it contains a different origin, or even if but the request needed credentials, then the browser steps in.
And throws that CORS error we all know and love in the developer console.
That's the one. The browser enforces the policy because the server didn't explicitly grant permission via the correct CORS header.
Makes sense. It's a dialogue using headers. Now, I've heard CORS requests aren't all the same. There are simple ones and others.
That's right. They fall into two main categories: simple requests and pre-flighted requests. The browser treats them differently.
Okay, let's start simple. What makes a request simple?
A request qualifies as simple if it meets a strict set of criteria. First, the HTTP method must be GET, POST, or HEAD.
Okay, just those three.
Yep. Second, apart from headers, the browser adds automatically, like origin or user agent. You can't have any custom headers.
Yeah.
Things like authorization tokens immediately make it non-simple.
No custom headers. Got it. Anything else?
One more thing. If it's a POS2 request sending data, the content type header has to be one of only three specific values: application XWWW form Erlang encoded multi-part form data, or text plain.
So basically like a standard HTML form submission.
Pretty much, yeah. If your request fits all those conditions, it's considered simple.
And what happens with a simple request?
For simple requests, the browser just sends it directly to the server, including the origin header. If the server responds with the correct access control allow origin header matching the request's origin, the browser allows access. Done.
Nice and easy. But most modern API calls probably don't meet those criteria, right? Like sending JSON or using put delete methods.
Exactly. Anything using methods like put, delete, patch, or others.
Yeah.
Or if you include custom headers like authorization or maybe an XAPI key.
Which is super common for APIs.
Totally. Or if you set the contact type to something like application JSON, which is also very common,
Right.
then the request is not simple, and it becomes a pre-flighted request.
Pre-flighted. Sounds like it needs permission beforehand.
That's exactly what it is. Before sending the actual request, like your PSAT request with JSON data and an authorization header, the browser first sends a preliminary check.
A check. How?
It sends a separate HTTP request using the options method to the same URL. This is the pre-flight request.
So it doesn't send my JSON data yet. It just sends this options thing first.
Correct. This options request basically asks the server, hey, I want to send a request from this origin header, using this method, like PUT, indicated by an access control request method header, and including these custom headers, like authorization, indicated by access control request headers. Are you okay with that?
Wow, okay. It's literally asking for permission for the upcoming request details.
Precisely. The server then needs to respond to this options request.
And how does the server say yes to the pre-flight?
It needs to respond with specific access control allow headers. Crucially, it must include access control allow origin, matching the requesting origin, access control allow methods, which must include the method the actual request wants to use, like PUT, and access control allow headers, which must include the custom headers the actual request wants to send, like authorization.
So it has to explicitly list the allowed methods and headers for that origin.
Yes, if the server's response to the options request includes all the necessary permissions.
The browser gets the thumbs up.
Exactly. The browser sees the successful pre-flight response and says, okay, the server's cool with this. Then and only then does it send the actual PUT request with the JSON data and authorization header.
And if the server doesn't respond correctly to the options request, or doesn't allow the method or headers,
Then the pre-flight fails. The browser stops right there, doesn't send the actual PUT request, and you get
the CORS error again.
the CORS error again. So pre-flight is an extra safety step for potentially riskier or more complex requests.
That makes a lot more sense now. So knowing all this, how do we actually fix CORS issues when we hit them? Let's say I control the backend API.
Right. If you control the backend, configuring the server is definitely the best and most proper way. You explicitly tell the server which origins are allowed to talk to it.
Can you give an example, like in Node.js maybe?
Sure. In Node.js, using something like the popular CORS middleware for Express, it's pretty straightforward. You could configure it to allow all origins, maybe like app.use, but be careful with that in production.
Right. Allowing everyone might not be ideal.
Definitely not always. More typically, you'd configure it to allow only specific origins. So you might pass options like origin https.myfrontend.com to the middleware. That way, only requests from https.myfrontend.com get the right CORS headers back.
Okay. And what about other environments, like Java with Spring Boot?
Similar concept. In Spring Boot, you can use annotations like across origin on your controller methods or configure it globally. You'd specify the allowed origins, methods, headers, and even things like whether credentials, like cookies, are allowed.
So you can get quite granular with the permission.
Very granular. You might say allow get and post from https.bonk.io for the AP path, and allow the authorization header, and yes, allow credentials.
You mentioned Spring Security earlier. Does that complicate things?
It can if you're not aware.
Yeah.
Basically, with Spring Security, you also need to configure CORS within the security filter chain. Typically, the CORS filter needs to run before your authentication or authorization filters. Otherwise, the security filter might reject the pre-flight options request before your CORS configuration even gets a chance to handle it.
Ah, okay. Order matters. So configure the server, that's the ideal path. But what if I don't control the backend? Say, I'm using some third-party API that just isn't configured for CORS from my domain.
That's a common problem.
Yeah.
In that case, a proxy server is often the way to go.
A proxy, how does that help?
Well, instead of your front end at https.myfrontend.com trying to talk directly to https.thirdpartyap.com, which fails because of CORS.
Right.
Your front end talks to a backend you do control, let's say https.myproxy.com API. This request works fine because it's same origin, or you configure CORS correctly on your proxy.
Okay.
Then your proxy server, https.myproxy.com BPI,
Right.
takes that request and on the server side forwards it to the actual https.thirdpartyapis.com. The third-party API sees the request coming from your server, not the user's browser, so the origin header isn't the browser's origin, and CORS isn't typically an issue between servers.
Ah, I see. The proxy acts as a middleman.
Exactly. The proxy gets the response from the third-party API and then sends it back to your front end. As far as your browser is concerned, it only ever talked to https.myproxy.com, which is allowed.
That's quite a clever workaround. A bit more infrastructure, but it solves the problem.
It does. Now, there's one other thing people sometimes use, especially during development: browser extensions.
Right. I've seen those, like allow CORS or something. Do they actually work?
They do work in the sense that they essentially tell your browser to ignore the missing or incorrect CORS headers from the server. They basically switch off the browser's enforcement of the same origin policy for cross-origin requests.
So they just let everything through.
Pretty much. Which is why they can be useful for local development or debugging when you're quickly trying to test against an API you don't control and can't proxy easily.
But I sense a but coming.
A big but. You should never ever rely on these extensions for anything other than temporary local testing. And definitely never ask your users to install one.
What?
Because they turn off a fundamental security feature of the web. If you browse the internet with one of those extensions active, you're essentially disabling the same origin policy protection for all sites, making you vulnerable to the very attacks SOP and CORS are designed to prevent.
Okay, loud and clear. Development tool only, disable it afterwards. Got it.
Please do.
Okay, one last thing before we wrap up. CORS often gets mentioned in the same breath as CSRF. Are they related? Do they solve the same problem?
That's a really important point, and they are often confused. But no, they address different security concerns.
Yeah.
They are not the same, and configuring CORS does not protect you from CSRF.
Okay, so CORS, as we've discussed, is about the server giving permission to other websites' origins to make requests. It controls read access, essentially, and permission for complex requests. What's CSRF then?
CSRF stands for Cross-Site Request Forgery. It's an attack where a malicious website, email, blog, instant message, or program causes a user's web browser to perform an unwanted action on a trusted site when the user is authenticated.
Okay, can you give an example?
Sure. Let's go back to the bank example. You're logged into mybank.com. You then visit evil.com. Evil.com could have hit her code, maybe an image tag or a form that auto-submits, that tries to make a request to mybank.com transfer.amount 1,000 into attacker.
Oh, no.
Because you're already logged into mybank.com, your browser might automatically send your session cookies along with that request triggered by evil.com. The bank server sees a request to transfer funds, sees your valid session cookie, and thinks you legitimately initiated it.
So it makes the transfer, even though I didn't click anything on the bank site?
Potentially, yes. That's CSRF. The attacker is forging a request on your behalf by leveraging your existing authenticated session.
And CORS wouldn't stop that.
Not necessarily. CORS primarily governs whether evil.com's JavaScript can read the response from mybank.com. It doesn't inherently stop evil.com from sending certain kinds of requests, especially simple ones like GT requests or simple POSTs that might trigger state changes on the server if cookies are sent automatically.
Wow. Okay, so they're fundamentally different threats. CORS is about controlling access from other origins. CSRF is about preventing unwanted actions initiated from other sites against a user session.
You got it. Preventing CSRF requires different techniques, like using anti-CSRF tokens, checking the referrer header, though less reliable, or using same-site cookies.
That sounds like a whole other deep dive.
It definitely is. Maybe one for the future. How to properly defend against CSRS.
Absolutely. Okay, so to recap CORS, it's the mechanism allowing servers to specify which other origins can access their resources, overriding the default same origin policy. It uses HTTP headers like origin and access control allow origin.
Right, and we have simple requests that often just work if the server allows the origin, and pre-flighted requests using options for more complex scenarios involving methods like put lead or custom headers.
And fixing it usually means configuring your server correctly, using a proxy as a workaround if you can, and definitely not relying on browser extensions in production.
Exactly. Understanding CORS is key to building web apps that can securely interact across different domains. It prevents the bad stuff while enabling the good, interconnected web we need.
Fantastic. Well, hopefully this clears up some of the mystery around those CORS errors for everyone listening.
Fingers crossed. It's a hurdle, but once you get the concepts, it